The four characteristics that we just went over are summarized in this key idea box, so I strongly encourage you to read through the key idea box carefully and maybe make some notes for yourself. So when we want to summarize an association between quantitative variables, we consider direction, form, strength, and we also note whether there are any unusual observations. Now, I mentioned previously we also have this summary statistic called the correlation coefficient, and the symbol that we use for that is a lowercase r. Now, the correlation coefficient measures the strength of a linear relationship between two quantitative variables, and it also indicates direction. So if the value of r, the correlation, is negative, then the direction of the association was negative. And if r is positive, then the direction of the association is positive. Now, I'm going to go back to this guidelines that we had. So again, we can use the far right column in terms of what we visually see with the scatter plot, and now we have the far left column to give us sort of guidelines about the value of that correlation and what that says about the strength of association. And again, notice it says same strength results with negative correlation. So correlations are always between -1 and 1. And the closer the correlation is to either 1 or -1, the more closely the points fall in a straight line. And the closer the correlation is to 0, whether it's positive or negative, the less strong the association is, and the less like a line the points will look. So in number 13, it says, will the value of the correlation for the year plate size data be negative or positive? It will be positive, since we already said that the association, or the direction of the association, is positive. So once you know the direction of the association, and we said that in number 9, so I'll just make a note here so you can look back at that. Once we know the direction of the association, then we know the sign, SIGN, of that correlation coefficient. Now, the formula to compute that is pretty complex, and we never compute it by hand. We always use a computer and your calculator, if you know how to do it, depending on the kind of calculator you have, could find it for you as well. Now, number 14 says, without using the applet, give an estimated range for the value of the correlation coefficient. So again, back in number 11, we said the strength was moderate. All right, so in number 11, we said the strength of the association was moderate. Okay, so that means correlation should probably be between 0.3 and 0.7. Now, there is a way in the applet for you to get the correlation coefficient. There's a little box for that. So if you go to the applet and check the box for correlation coefficient, then you'll see R equals 0.604. So I'm going to go back to my screenshot up here and just again point that out. Correlation coefficient. If you check that box, it will calculate it for you. So 0.604, notice, is in between the 0.3 and 0.7. It is in the moderate range. Now, the key idea box here is important. the correlation coefficient is only applicable for data which has a linear form. So if the data does not have a linear form, then we shouldn't be using the correlation coefficient, right? And it says, in fact, we could say the correlation coefficient is a numerical summary of the strength and direction of a linear association between two quantitative variables. So previously we said we could summarize an association by looking at form, direction, strength, and whether there are any unusual observations. Once we know the form is linear, then we could use this correlation as a numerical way to summarize strength and direction. Now, the other point that they're making here is that the correlation coefficient is sensitive to influential observations. So they're asking us to add a point at 1950, 11.5, which is the one that we talked about earlier, and see what happens to the correlation. So if we go back to the applet, and in the add or remove, let me just bring this down a little, we add an x value of 1958 and a y value of 11.5 for diameter, and click on add. Now, if we scroll down in our data box, we'll see that point is there. And notice what happened to the correlation coefficient. It went from 0.6 down to 0.4. So that's a pretty big difference. It's still in the moderate range for strength, but it's quite a bit lower. This is closer to weak, whereas the other one was closer to strong. And you can see the point. I can't circle when I'm in the internet, but you can see the point in the upper left part of the scatter plot. Okay, so in this case, the correlation went down. It decreased from R equal 0.604 that it was originally to R equal 0.417. And again, we would consider that a pretty big drop. Okay, now one more thing I want to show you. It would be good for you to get some practice in understanding the relationship between the correlation and the scatter plot. So there's an applet called Correlation Guessing Game. Okay, it's on the far right in the middle row, Correlation Guessing Game. Now you can change the number of points, but I'm just going to click on New Sample. And so I see a scatter plot, and what I'm going to try to do is guess what the correlation is. So I don't have any experience with this yet, so I'm not really good at it. It looks to me like the direction is negative, so I'm going to guess a negative value, but the points don't look like they're in much of a straight line, so I'm going to try 0.3. And then I click check guess, and it says, nope, it was negative 0.206. Well, that wasn't the worst. Then I'm going to click New Sample, and now there's definitely a negative direction here, so my correlation guess will be negative, but also I see that these points are much closer to a straight line, so I'm going to guess 0.75. And I was pretty close. The correlation is actually negative 0.702. So I would recommend that you spend a little time with this, pretend it's a fun video game, and practice guessing the correlation and try to get better at learning how these numbers are related to what the scatter plot looks like.